Hi, this is Pete Lyons with Let's Play Salesforce, and it wouldn't be new release coverage if Bobby wasn't here. It just wouldn't feel right. So even though we're a little later than usual, yes, that's totally my fault. We are here to cover spoilers for Einstein Discovery for the Spring 22 release. So with that said, Bobby, I hand it over to you.
Awesome. Thank you, Pete, for inviting me once again to your show. I enjoy doing this. I'm going to start again in Salesforce reports and highlight a feature that we did with Einstein Discovery for reports in the spring release. So here I am on a cases report. In fact, I'm going to focus a lot of today's demo around service use cases, because I think there's a lot of ways where service data can be analyzed and predictions can be applied, and you can get a lot more out of your service data. I'm going to start with this report that looks at cases, kind of some generic demo orgs type stuff. I'm going to click the Analyze button. And if you're looking at a report and you've got Einstein Discovery for Reports access, the first time you click Analyze, it's going to immediately go and do an analysis of the occurrences of all the information. And we thought, you know what, the first thing that we should show is really how more of like a column profile type view, because the first kind of view that you get, you don't really understand what we're doing. So we took a step back and said, okay, well, let's show you each column by sort of this profile. So if it's a number column, we're going to show you the kind of the range and the median, the mean. I think we've got median coming in a patch, but you can see just sort of a breakdown of data. And we've added some additional charts as well. So if it's, I think, less than 5 classes, we're going to give you this pie chart that just kind of shows you distribution of things. And then we're going to show you things that kind of occur most frequently. But the biggest thing here is we've added these little Einstein buttons to the columns where you can do further analysis. So if it's a number field, you can analyze it further, as well as a binary field. So in fact, I can click this, and then I'm now brought back to this home page where now I can see, hey, I can do this additional analysis. So we're just trying to make Einstein Discovery for Reports a little bit more discoverable for our users to get a little bit more value out of them. But the thing I'm most excited about in the spring release is a new way of a new type of prediction that we can do. So before we had binary classification and we were able to predict numerical fields. But what's really exciting is now we can predict multiple classes. So in fact, up to 10 different classes. So it's no longer just binary, it's multi-class classification. I'm going to start here in a lens. Again, we're looking at cases. I'm going to give you a quick preview of the data that we're looking at here. So I've got industry, I've got a field saying whether things are escalated, I've got a status, functional area, description. I took some case data and I obfuscated a lot of it. So some of it is real, some of it is fake. And what I'm really interested in is figuring out the predicted status. In fact, I may have shown you this in our last video, but now it is GA, and I can click the little Einstein head. You'll see it's a little bit different. You can now search for the outcome field. This seems like a very simple fix, but if you ever had a giant data set with, like, let's say 200 fields, and you had to scroll down to find it, when you knew, I just want to type it in, we made that a little bit easier. And then next, choose my insights and prediction. And let's go to the manual page so I can just show you what all this looks like. So with multi-class classification, we support only your GBM, XGBoost, and random forest models. These are our tree-based models. We're going to default to GBM. This one should process the fastest. The last release, we offered different validation options. I think we changed the label in this one in this release, but you can still update or add a separate holdout validation data set or change your training validation ratio within the one set. So that was functionality that we got in the last release. So I can choose my columns of data and create my story. But we're not going to sit here and wait for the story to create because we already have it done here. So when the story is complete, we're now looking at what is driving various classifications of data. So our summary panel here, so we didn't have this in the pilot, so part of the GA release, we have a summary panel that shows kind of different statuses that occurred the most. So I know that closed resolved is occurring the most. So this is, again, when a case is closed, what is the how is that case closed? What's the disposition of it? So it's either resolved, or in this case, no action taken, or maybe it was a duplicate, or is routed to internal help desk. So there's all kinds of options of how a case is going to end up. And wouldn't it be great to know what that is ahead of time so you can kind of better prepare? And I can see here, closed resolved actually happens a lot when case origin is self-service. So people that are logging their cases through the self-service portal, they're getting their cases closed, resolved more frequently. So I can actually drill into this a little bit more. And here's where we've got explainability on top of that data. So this is the sweet spot of Einstein discovery is we give you explainability on your model, so you can really understand what's going on. We're using a technique called SHAP to be able to explain the different impact of the various fields to show how they're reaching the outcome. And in this case, this global average is sort of I guess it's the overall occurrence for this this field. So it occurs kind of most frequently in the data set. And at the very bottom, we've got the occurrence when case origin is specifically self-service. And I can see it's slightly less than over the entire average. And I can get kind of, here's my my positive impact, here's my negative impact. And then I can, on the left, see a little bit, understand a little bit more. So I can now get explainability on my data to see kind of why things are reaching these certain statuses. I can compare, so I can compare self-service to perhaps chat, and I can see where chat sort of outperforms, self-service outperforms chat, or self-service falls behind chat. And this again is relating to this this status of closed resolved. So I can see more often when I'm self-service, do I end up with closed resolved when description is cluster 2. And what is description cluster 2? That's a feature I'm about to show you in a little bit. We have the ability to do text classification on big text. It is a pilot feature, but I will show you that in just a little bit. So now I can review my alerts. So this was a feature we gave you in the last release. I think there's one additional alert here. I don't actually have it to show you, but we're further detecting data leakage for certain cases. So if there's I think it's if there's a class, or if there's a category where a certain classification happens 100% of the time, we're like, hey, there's probably something you're telling our model how to predict, so you should probably remove this. So I can check out my data alerts, and I can go ahead and deploy the model. So we made a couple updates to this page, mostly usability related updates. By default, if I've already deployed this model, it's going to recommend that I update my existing model, or update an existing model I have out there. I can always deploy it as a new prediction and model. In fact, if I chose deploy as a new model and a new prediction, I get to name the model, and then I get to name the prediction definition. The two are sort of separate. A prediction can have multiple models, and a lot of customers don't really understand that we support this really awesome feature of model segmentation. So we tried to change the UX of the model deployment to really highlight that the two things are different. But I can update a model, and then I can choose which active model to update. And then if I am just updating a model, when I click next, I no longer have to go through the entire page. I'm just taken straight to the end where I can review my settings and I can deploy. So we tried to clean that up and make it a little bit easier. Now, why do I want multi-class classification? Well, I want to understand my data back in Salesforce a little bit better, or it could be data that doesn't live in Salesforce, and it's in an analytics data set. But I want to understand kind of my data a little bit better. So I'm going to flip back to Salesforce, where I have an open case. And what I can see here, so the case was just created, it's been escalated, but it's still open. But based on all the data in the case, we're still predicting that it's going to be closed resolved. at a 48% probability. I have the option, so with this lightning card, I have the option to show all of the ranked probabilities, or I can exclude this, and then I can just see my predicted status. I can see top predictors for this, but there's no improvements because my outcome is multi-class classification. There's no way of telling the system really like which one is better. So I wouldn't necessarily want to tell users, hey, you should assign this to tier 3 because that's going to make it close resolve. Then we'd have to add all this kind of all this stuff in the product to say, hey, this class is good, this class is bad, and I think it would get a little bit more complicated. So we don't really have the improvement variables here. But you might be telling yourself like, hey, this is great. I have a lightning card where I can see the prediction, but really, that's not really driving my my process. So one of the things we did in the last release, and I love Flow, is we added an Einstein discovery action in Flow. So now every time this record gets updated, it could kick off a flow and we can reevaluate the status. So what if we could do stuff with that? What if we could look at that status and make additional kind of process changes automatically? So I'm going to flip to my flow here. So what I have here is a record triggered flow. The Einstein discovery actions are only supported in the asynchronous run. And that's because when we do our prediction, it calls out, it's technically a call out from Salesforce, even though it's still within Salesforce. It's still a call out to the analytics, the analytics engine within Salesforce. So it's unfortunately only supported, at least now, in the asynchronous branch of a flow. And here I can actually do multiple models here. So I'm predicting the escalation. So this was just a binary classification model. So I'm predicting whether or not this is going to be escalated. I can check that prediction. So it's all declarative. So I connected to my model, and I'm checking for my prediction. So I've got this this outcome from prediction. So this is the output from my predict case. There's a value of the prediction. So I'm just checking the output of that to see if the prediction is greater than 60. So is the likelihood greater than 60? So we think it's likely to escalate. Well, now let me check the case status. So let me just show you how this is done. Got an action, choose Einstein discovery. I'm predicting the status. I guess I have two models out there. Predicting the status, I can give it a label. I can get my prediction, my top predictors, if I want them. I also get the ranked probability, so that's included with the prediction. So I get not only that prediction, but everything else. And I either have the option to pass in a record ID. Since this is asynchronous, I know I have a record ID. But if you're building like a screen flow or something like that, you can just map the fields directly. Get your prediction, check your prediction, and in this case, I'm checking the output. The output's going to be a text because it's a multi-class classification, and I can check to see is it no response from customer. If we're predicting it's no response from customer, well, guess what? I want to notify the account team. So we have a case that's likely to be escalated. We're predicting that it is the customer's probably going to abandon it. Let's get the account team notified. So now I can take that prediction and actually can start driving my process with my team. So a lot of options that you could do here with this. Also, next best action has moved to the flow builder. I believe that's GA in the spring release as well. So if you're building next best action, you have access to the Einstein discovery flow action as well. So we didn't just stop there. We, of course, wanted to make sure we had the capability within recipes. So I can quickly add a discovery predict node here. I can find my multi-class classification model. So you'll see the type will say multi-class classification. I can click my predicted status, choose or map my fields, include top predictors. Again, there's no top improvements because they're not supported for multi-class predictions. And apply here. And then I get a new field that gives me the predicted status, and you're going to get a text of the predicted status. What we don't have yet is the ability to get those ranked probabilities in recipes. This is something that we're going to try to add in a future release because I can see it being very useful. All right, so now a couple other new things that I want to show you. We made some changes to Model Manager. We wanted to make it easier to find and edit your models a little bit better. You'll notice on the left-hand side, there's these little pencil icons. So this is how you can edit different pieces of your model. So I can quickly edit, if I want to edit the mappings, I just click that pencil. Or now if I want to edit the object that something's connected to, I can go ahead and click that. The use case here is usually you're going from, I deploy, I don't want to connect it to an object, and then I'm like, hey, later on, I want to add it to an object. We didn't have the ability to do that before. So now we do. And you might be noticing this new review alerts button. So in the past, we had a lot of prediction warnings. In fact, so many warnings that I had customers that showed like 8 million prediction warnings, because every time we make a prediction, if anything is either out of bounds or missing, we highlight that in these alerts. So we decided to say, hey, if instead of having millions of alerts, let's just throw an alert if a field in your model has a problem. So I can click this review alerts. So now if a field has a problem, you're going to see it here. So description, it has out of bounds values. And I get a bar chart that shows how many of all my predictions that are made. I have essentially six out of 6 predictions are out of bounds. So I have a problem with this field. What it means is it's making a prediction on data that it doesn't know what to do with. Description, this was the pilot feature I talked about where I was looking at text clustering. Basically, the description that I have has text values that didn't exist in the clustering. So when I trained the model, certain text values existed there and the actual data doesn't exist. So it's telling me that I've got out of bounds. But we're giving you some information on what you can do to fix it. And then I've got these 3 number fields that have missing values. So it's Einstein's detected missing values. For text and numeric variables, consider applying a transformation in story settings to replace missing values. So this is a feature that we've had. In fact, for numerical fields, we had it. For text, it's a pilot. But we have a way to actually fix the missing value problem. So I can go to view story. Those happen to be number fields. So I'm going to show you the GA feature that we have. I can click edit and I can say, hey, I have this number field and I want to apply a missing value transformation to it. So replacing missing values for numbers it's a simple calculation. You can take the average, median, or mode for a different category in here. So in this case, I might want to look at the average for the industry that this customer is coming from, potentially. So it's basically saying, okay, so where we do know the support case owner count, we're going to take the average for all of the cases where the industry is the industry that we happen to be replacing. So I can do this for each one. I don't know why I can't replace that. That's interesting. Apparently I can only do 1 per story. So this is something new to me. I got to figure out what's up with that. So you can keep that in, by the way, because I didn't realize that was going to happen. Seems like for numbers we should allow more than 1. So I will make sure that I get to the bottom of that one. I can make a change and I can fix my missing value problem, and I can then update the story and redeploy the model again. So that is the prediction alert. The next kind of really cool GA features, this was pilot in the last release, is the ability to fix imbalanced data problems. So we have this bike ride data set, and what I'm really interested in is looking at the subscription type. So if I look at the field, what I can see here is it's pretty imbalanced. Most of the subscription types are subscriber, but what I really want to do is see where the subscribers convert to customers. As you can see, 20,000 versus 566,000. this is considered an imbalanced data set. So traditionally, Einstein discovery hasn't been great on imbalanced data. In fact, we told you if it's less than 5% distribution, you shouldn't use Einstein discovery. Well, no more is that a problem. So if I do subscription type here, and I want to maximize customer, go to my insights and prediction, go to manual, it's going to alert me when the distribution is less than, I believe, 5%. So in this case, it's 96.6%. And what is that? 3.4%. And so I get this alert and it tells me, hey, I should apply this class weights. So I can click that. And then I create my story. So now I end up with a model that can actually handle this imbalanced data problem a little bit better. That's what the class weights are doing for me. So now I'm going to show you 2 additional pilot features that I'm really excited about. One I mentioned a little bit earlier. So what I have here is a churn data set. And I want to show you what data is in here. So what I have is industry, account segment. I've got some text data. I have my outcome field, and I have a monthly revenue. And I know that this monthly revenue changes all the time, but I've got a snapshot. I'm training my model with the snapshot of data. But really, this number, I know this number is going to change for my various accounts. So I'm going to show you a really cool new pilot feature that takes that into account. So I want to minimize the occurrences of churn. I'm going to go to insights and predictions, and I'm going to choose manual. So now we have the ability to create projected predictions. So what does that mean? So let's show you what that means. So I told you that monthly revenue is something that I know changes over time, and I can see it's very highly correlated in the likelihood of churn. So if I have a field where I know this number is going to change, I can actually use a combination of time series with my predictive model to make a more kind of a more intelligent prediction for the future. So what I do here is I choose my projected predictions column, and then I have to add a data set. So basically, we have to give the model all of this kind of time series data so it can make it can do its thing to predict for the future. So I've got this historic monthly revenue data set, and basically I've got different columns in this data set. So one is going to be my unique identifier. For each account, I'm going to have kind of many changes for monthly revenue. So I'm going to have so if I have like 10 months worth of data, I'm going to have 10 rows for every account, and each month is going to be a separate number. So in this case, I've got where's my monthly revenue column? Well, I have this revenue, and then I have my date field, and I want to do this monthly, and then I can choose how many predictions ahead do I want. And then I have the ability to choose seasonality. So what's happening is we have this data set, we're going to apply time series to this. So at the time of prediction, we're going to be able to predict churn 10 months ahead. So that's the goal here. So I set this up, I create my story, but because I don't want to sit here and wait for that, we're going to look at what this story looks like. So the story itself is not going to look any different because this is all about the prediction. But the other feature I wanted to talk about is text clustering. So what I did here is I have this survey response and I applied the text clustering transformation on it. And what it did was it looked at all the fields and it pulled out the keywords that it sees across all of the data. So in this case, it sees these 3 keywords 61% of the time, and it sees these 2 keywords 10% of the time, and these 9%. And I can actually edit this further to see kind of what goes into each bucket, so that if I wanted to kind of change any of these, I could change them. So again, this is a pilot feature. I think there's a lot of value for every model out there, because especially in Salesforce, there's a lot of kind of free-form text that gets added in. So I think there's a lot of great ways that we can unlock kind of the predictive signal from these text fields. But once I deploy this model, if I want to understand my churn 10 months from now, I can get my churn probability, and it tells me 10 months, and I have this cool link here. So if I click this, what it shows me here is the today, this is my revenue, and I can see my revenue is decreasing over time. Here is my churn prediction. So I go from a 60% likelihood to churn, and then it starts to go up to 89%, and then it sort of evens out. And then this is kind of the sweet spot where it's like, nope, now we really think the customer is going to churn. So it's a great way to understand kind of over time, what does this prediction look like, taking into consideration kind of a time series type data. So with that, I am going to end my demo.
So first, as always, awesome stuff. I'm very excited about some of the more forward-looking things, but as far as multi-class classification is concerned, that's the one I'm definitely going to be using the soonest, because the snag with pilot features is you can only use them in sandboxes until they actually go GA. So it's nice to play with this stuff, but I'm just really pumped when I do see something really awesome that I've been waiting for go GA. And then there were two questions that I had that you didn't really cover, which was and because I kind of think it's unrelated. So you ever run a data flow and use the prediction node, and now let's say you got a whole bunch of garbage data in your system that you do still want to run your model against, but it doesn't have any place in your training data set. So as a result, you will get a lot of out of bounds errors, and then you have to explain to your client, no, this is to be expected. This is not the whole machine breaking apart. And as you were going through like those the warnings in the monitor and everything, that's what got me thinking. Will now I know data flows are kind of, no, we're not doing anything for them, but can we maybe ask for something similar?
So do you mean in recipes?
No, in standard data flows, when using the prediction node, and you score a data set that has values that are not found in the training data set, you'll get out of bounds warnings.
Sure. Yes, correct. Then those won't even show up in your model manager. Recipes ones will, however, show up in model manager. So here, like, to get to the bottom of everything, data flows and recipes from an engineering perspective are two separate things. So if we want to make a change in recipes, we do it in one place, and then we have to sort of duplicate the effort to do it in data flows. So what we decided was data flows, what we have is good enough. And since recipes is where everything is, all the new innovations happening, we're like, let's just stick with recipes. So it's sort of a way, because we have sort of a lean team, if we want to get things done, I sort of made the call that, sorry, data flows are not going to get any extra love from the prediction.
Yeah,
so I'm very sorry.
The messaging I've been hearing for a couple of years is, we will fix bugs, we will not add features. Okay.
Yep.
Yeah, which is fine, because I mean, like, data prep's come a real long way. Like, if you had told me like you were disabling data flows like 2.5 years ago, when or even further back, like when recipes were first released, I would have been a little worried. Then the other one is related to the clustering, and this is also kind of a recipes thing, because we have clustering in clustering in recipes, and I'm going to use, I'm much more of a data artist than a data scientist, but I did learn that the clustering, it only works in numerical values in recipes, and it's because it uses the k-means algorithm.
That's correct.
By contrast, you must be using the k-mode algorithm.
We are using TF-IDF.
Okay, so I'm completely wrong on that. But is there the underlying question is there any overlap between the machine learning growth for recipes and what your team is doing? Do you guys benefit from one another? Like, obviously you're hanging out in the same spot, but you know, how much interplay is there? Yeah,
so there, one of the things you may have noticed, we have sentiment detection, and recipes has sentiment detection. In fact, recipes had it before Discovery did. And we said, hey, there's this really great sentiment detection model out there. Can we use it in Discovery? And they said, yeah, of course. Let's have one model and use it in both places. So there's a recipe transformation and there's a sentiment detection in discovery. And then one of the first transformations we built was typographical clustering, which is let's fix kind of misspelled words. This is a common occurrence for like leads, because leads are usually a form that you type in. And so we built a typographical clustering algorithm, or not algorithm, sorry. We utilized a typographical clustering algorithm. We called it fuzzy matching. And then we said, hey, recipes could benefit for this. So we actually built the transformation recipes. So the idea is we want to have both in both places if we can. It does require a little bit extra work, but the way that we're building the models are ways that both can utilize them without too much extra work. So then it becomes just sort of a UX type thing. So we want to have both in both places. What we call them is really important, right? Because we call our feature text clustering because that's what it's doing. For the user who's using our system, that makes the most sense. In recipes, calling it text clustering may get confusing. It's probably to the point that you made with that we call it clustering there, and it only works with numerical variables. So we're thinking through this the best way that we can, but we know that both can utilize or can benefit from these transformations.
All right. Well, that's all I had to ask. Thanks for hanging out with me and SpongeBob.
Always.
And so and then for the folks at home, if you enjoyed this, please like, subscribe, tell a friend, and as always, thanks for watching.
Look at this. This is what I get for my demo that was partially ready. Quickly show you kind of what's in this data set. So we're looking at bike rides, and I am trying to predict, gotta remember what I'm trying to predict here. I'm trying to predict the, oh no. Uh-oh, give me a second. We're gonna edit this one out. I gotta remember what I'm predicting. Subscription type, okay. All right, so I have this bike ride data set here. Oh my God, I already forgot what I was predicting. The subscription type, woohoo. All right, so we have this bike.
Take it from the top. Take
bike
it from
ride.
the top.
So if I choose, oh my goodness, where's the transformation text? Wow, it's gone. Somebody turned it off. How did this happen? Oh my God, did this break somehow? Uh-oh.
Do you have any interns you can blame?
I mean, give me 1 second.
What, are you going to get an intern?
No, we have another SpongeBob moment. This is like my most SpongeBob moments. It's gone. All right, let me take it from the top here. All right,